Hello, Assalamualaikum guys. I will be explain to material first vector in R power 2, vector in power 3, and 3 the dot product and less the cross product. First material 1 and 2 vector in R power 2 and R power 3. Okay. The term vector is used by scientists to indicate a quantity such as displacement or velocity or force that has both magnitude and direction. A vector is often represented by an arrow or a directed line segment. Maksudnya adalah istilah vektor digunakan oleh para ilmuwan untuk menunjukkan besaran seperti perpindahan atau kecepatan atau gaya yang memiliki besaran dan arah. Nah, yang pertama, the length of the row represents the magnitude of the vector, and the arrow point in the direction of the vector. We denote a vector by printing a letter in the face or V, putting an arrow above the letter or vector V. Vektor ini sering diwakili oleh panah atau segmen garis berarah. Panjang panah mewakili besaran vektor dan panah menunjukkan ke arah vektor atau vektor V seperti pada penjelasan tersebut. Suppose a particle move along a line segment from points A to point B. The corresponding displacement vector V shown in figure has initial point A or the tail and the terminal point B or the tip, and we indicate this by writing V equals vector AB. Notice that the vector U equals vector CD has the same length and the same direction as V, even though it is in a different position. We say that U and V are equivalent or equal, and we write U equals V. Suppose a particle move from A to B, so its displacement vector is vector AB. The combined effect of this displacement is that the particle has moved from A to C. The result displacement vector AC is called the sum of vector AB and vector BC, and we write vector AC equals vector AB plus vector BC. Definition of vector addition. If U and V are vector positions, so the initial point of V is at the terminal point of U. Then the sum U plus V is the vector from the initial point of U, the terminal point of V. We start with the same vector U and V as in figure before and draw another copy of V with the same initial point as U. Complete the parallelogram, we see that U plus V equals V plus U. This also gives another way to construct the sum. If we place U and V, so they start at the same points. That's U plus V lies along the diagonal of the parallelogram with U and V as sides. This is called the parallelogram rule. Example, Draw the sum of the vector A and B shown in figure. Nah, bisa kita lihat vektor A dan B pada gambar tersebut. And solution, first we move B and place its tail at the tip of A, being careful to draw a copy of B that has the same length and direction. Nah, kita bisa memindahkan vektor B ke ujung arah vektor A dan menempatkannya dengan searah yang sama. Then we draw the vector A plus B start at the initial point of A and ending at the terminal points of the copy of B. Alternatively, we could place B so it start and construct A plus B by the parallelogram law as in figure. Multiplying vector. It is possible to multiply a vector by a real number C. In this context, we call the real number C a scalar to distinguish it from a vector. For instance, we want 2p to be the same vector as p plus p, which has the same direction as p but is twice along. In general, we multiply a vector by a scalar as follows. Scalar multiplication. Definition of scalar multiplication. If C is a scalar and P is a vector, then the scalar multiplies C. P is the vector whose length is C times the length of P and whose direction is the same as P if C does not and is opposite to P if C minus 0. If C equals 0 or P equals 0, then CP equals 0. We see that real numbers work like scaling vectors. That's why we call them scalar. Notice that two non-zero vectors are parallel if they are scalar multiples of one another. In particular, the vector min p equals min 1 power p has the same length as, the vector min p equals min p times p has the same length as p but points in the opposite direction. We call is the negative of p. By the difference u minus p of the vector, we means u minus p equals u plus minus v. So we can construct u minus p by first drawing the negative of p and min p and then adding it to u by the parallelogram law in figure. Alternatively, since p plus ru min p equals u, the vector u minus p, when added to p give u, so we could construct u minus v as in figure by means of the triangle law. Notice if u and v both start from the same initial point, the u minus v connects the tip of v, the tip of u. If a and b are the vectors shown in figure, draw A minus 2B. Bisa kita lihat pada gambar, itu adalah vektor A dan B. Pada gambar sebelumnya itu adalah gambar vektor A kurang 2B. Nah, solusinya, we first draw the vector minus 2B point in the direction opposite to B and twice as long, we place it with its tile the tip of A. And then use the triangle law to draw A plus minus 2B as in figure. Jadi kita dapat gambar vektor dari A kurang 2B pada gambar berikut ini. Components. For some purpose, it's best to introduce a coordinate system and treat vector algebraically. If we place the initial point of a vector at the origin of a rectangular coordinate system, then the terminal points of a has coordinates of the form A1 and A2 or A1, A2, and A3, depending on whether our coordinate system is 2 or 3-dimensional. These coordinates are called the components of A, and we write A equals A1, A2 or A equals A1, A2, and A3. We use the notation A1, A2 for the ordered pair that refers to a vector so as not to confuse it with the order pair A1, A2 that refers to a point in the plane. For instance, the vector sounds in figure are all equivalent to the vector OP equals 3.2 whose terminal points in P 3.2. In 3 dimension, the vector A equals vector OP equals A1, A2, and A3 is the position vector of the point P, A1, A2, and A3. Let's consider any other representation, A vector AB of A, where the initial points is x1, w1, and z1, and the terminal point is B, x2, w2, and z2, then we must have x1 plus a1 equals x2, y1 and a2 equals y2, and z1 plus a3 equals z2, and so a1 equals x2 minus x1, and a2 equals y2 minus y1, and a3 equals z2 minus z1. Position vector. Equation 1. Given the points A, x1, y1, and z1, and b, x2, y2, and z2, the vector with representation vector AB is A equals x2 minus x1, y2 minus y1, and z2 minus z1. Example, find the vector represent by the direct line segment with initial points A, 2, min 3, and 4, and terminal points B, minus 2, 1, and 1. Solution. By first, the vector correspond to vector AB is A equals min 2, min 2, and 1 minus min 3, and 1 minus 4. And then equals min 4, 4, and 3. Length vector. The magnitude or length of the vector phi is the length of any of its representation and is denoted by the symbol phi or P by using the distance formula to compute the length of a segment OP, we obtain the following formulas. The length of the two-dimensional vector A plus A1, A2 is A equals akar A1 kuadrat tambah A2 kuadrat. The length of the three-dimensional vector A equals A1, A2, A3 is mutlak A sama dengan akar A1 kuadrat ditambah A2 kuadrat ditambah A3 kuadrat. Algebraic vector. Figure show that A equals A1, A2, and B, B1, B2. Then the sum is a B. A plus B equals A1 plus B1 and A2 plus B2, at least for the case where the components are positive. In other words, to add algebraic vector, we add corresponding components. Similarly, to subtract vector, we subtract corresponding components. From the similar triangle in figure, we see that the components of CA are CA1 and CA2. So to multiply a vector by a scalar, we multiply its component by the scalar. Algebraic vector. If A1, A2, and B, B1, B2, then A plus B equals A1 plus B1 and A2 plus B2. A minus B equals A1 minus B1 or A2 minus B2. CA equals CA1 and CA2. Similarly, for the dimensional vector A1, A2, A3 tambah B1, B2, B3 sama dengan A1 tambah B1, A2 tambah B2, A3 tambah B3. Maka didapat CA1, A2, A3 sama dengan CA1, A2, CA2, dan CA3. For example, if A for 0, 3, and B minus 2, 1, and 5, find A and the vectors A plus B, A minus B, 3B, and 2A plus 5B. Solution. Solution mutlak. A sama dengan akar 4 kuadrat tambah 0 kuadrat tambah 3 kuadrat sama dengan akar 25 sama dengan 5. A tambah B 4,0,3 ditambah min 215 dapat hasilnya 218. Dan A kurang B 403 dikurang minus 21 dan 5 dan didapat hasilnya 6,-1,2. Nah, di sini kita dapat 3B-nya yaitu min 6,3 dan 0,15 dan 2A tambah 5B yakni min 2,5,31. Properties of vector. Di sini ada properti vektornya. Jika A dan B adalah vektor dalam Pn dan C dan D adalah skalar, maka yang pertama yakni A tambah B sama dengan B tambah A tambah B tambah C sama dengan A tambah B tambah C. A tambah 0 sama dengan A tambah min A sama dengan 0, C kali A tambah B sama dengan C, A tambah CB, C tambah D kali A sama dengan CA DA, CA tambah DA, CD dikali A sama dengan C dikali DA, dan 1A sama dengan A. Nah, property 1 can be seen from figures. It's equivalent to the parallelogram law. Atau bisa kita tulis jika N sama dengan 2 yaitu A tambah B sama dengan A1, A2 tambah B1, B2 sama dengan A1 tambah B1 kurang A2 tambah B2 sama dengan B1 tambah B2 tambah A1, A2 sama dengan B tambah A. We can see why property 2, the associative law, is true by looking at figure and apply the triangle law several times. The vector P key is obtained either by first contrasting A plus B and then adding C, or by adding to the vector B plus C. Oke, thank you all. Assalamualaikum warahmatullahi wabarakatuh.
Cis, tolong masukin ke Word dong, Cis.